Okay, this is going to be about subtraction. So what we're going to do, we're going to get the adder. If you don't know how to make the adder, go back a tutorial. So I'm just going to move these lines back, and I'm going to delete the every number 2 bit input, and just delete all them. And now what we want to do is get an inverter logic gate. So let me find that. Inverter is another word for a a NOT gate. So let's make sure this is in line. Okay, the next thing you need to do is have a carry in on the carry in handler, I guess I would say. So I'm just going to copy and paste this, and that should rotate it. And there we are. So that's carrying in a bit and reversing the second bit. Now this is not actually needed because you can't get higher than 15 by subtracting. So this output's going to be used for later. So as you can see, this actually works fine as long as the number's positive. So let's try this. So number 2 bit 3, number 1 bit 3. So this is going to make a 4. 4 minus 3, we'll say, gives you 1. So you can see that works fine. So now what we need to do is handle the output as if it's negative. So if we do a number negative, so let's say it's 2 minus 4, we're going to get a wrong answer. So what we need to do is use this, because the output, if it's a negative, if it's positive, the output is on, and if it's negative, the output's off. So we can use this to handle to check whether it's positive or negative. So what we need to do is to move all these outputs. Okay, so I've moved these outputs down here. So these are the 4 bits, and this is going to be a bit to show if it's positive or negative. So let's do this. So what we want to do, if this is, when it's positive it's on, when it's negative it's off. So what you need to do is copy and paste this, and I'm going to put it over here. Okay, so that should be all fine. What we're going to do is use this input, so we're going to have an inverter to check for the one state and normal just for the other state. So what we can do is put everything in an AND gate. So if this is on and this is outputting, then send it to the output, and that's how we can check that. So I'm just going to copy and paste these for every gate. So just connect these up like so, and then connect this up to the other side of the AND gate. So it's saying if this is on, that means it's positive, and this is output number, then we want to carry the output to the output. So we're going to say carry this down to here, so that's bit 1. Bit 2 we can send just next to it. Bit 3. Okay, so that's checking whether it's positive. Now if you invert it, then if this is off, then this will be on. Okay, so now what we're going to do is going to account for whether it's a negative number. So I'm going to copy and paste these and put them like there. So that's checking whether it's a negative. So what we need to do is get the output from this and bend it around here, connect it up to that. I'm just going to move these forward a bit. Okay, it's just so it's easier to connect up. So just need to connect these up to the second leg, and the output from this up to the first leg. That's going to the wrong leg. So these connect to the AND gates. Okay, so if it is negative, then we want to send it into this bit, which is an adder. So basically what it does, it gets the bit and we need to reverse it and add 1. So that's what this carry-in is going to do. So we need to reverse it with an inverter. So I'll put it here. Okay, because we're only adding one number, we don't need one half of this, so I can delete this, and this doesn't need to be an OR gate, although it can stay an OR gate. So I'm just going to bring this a bit closer. So we're just going to add straight to this input. So let me just move this because it's not connecting very well. Okay, so we just connect these to this line here, and this input's just adding the 1, but it needs all this to handle the carryouts, and then you just simply send this output to the output. So let's go and do that. So that's bit 1. I'll connect it there. Okay, they're all connected up. Now this finally is doing an indicator where it's positive and negative. You can invert this if you want. I'm gonna have it on if it's positive, off if it's negative. So I should be able to just hook this up like this. Okay, just because of a issue with voltage and normal circuits, I've had to put an AND gate here just so it doesn't take the easiest route. And then yeah, I've just done that. That's a circuitry based problem, not logic. So if you do this, then you can see 1's on because it's coming from this output, because this is on and connecting and this is on and connecting, so that gives an output to this lamp. But this is subtractor, so let's get a number 7. So that would be the 4th bit, that bit, and that bit. So you can see it says 7 minus we'll say minus 2 will be that, which is 5. But if we were to minus, we'll say minus 10, I guess, then you can see it says 7 minus 10, so that makes 3, and then this is off to say it's minus.